When I work on a project of this type, I like to get the most complex parts done in the beginning. Um, that way I know I was, able to solve the most complicated problems, and it actually makes the rest of the build go easier. Anyway, this is the cylinder block, and it's one of the most complex parts, only because there are so many operations that have to be done on it. Um, it's it's roughly a 1 inch square and a little less than 2 inches tall. Um, Clearly, there are some boring operations that have to be done from both sides. Um, these holes are drilled and tapped for M3 screws. There's more boring that goes on through the top. And then there's this really just a visual item here, this little raised part. So my thought process is that, I'll begin by, taking some raw stock and using my fly cutter to square it and cut it to the final dimensions of this piece. And then I'll go ahead and I'll just drill and tap the 6 holes that need to be put into it. Then I think the next thing I'll do is I'm going to mount this on the lathe in the 4-jaw chuck, which should be interesting. I've never mounted a square piece of stock and tried to center it before. But I think that's the best way to cut this this feature here. Once that's done, I'll go back to the mill, and I'll show you this from the section view here. I'm first going to drill this this inner hole. That just comes in through the top, and that's what lets the air come in through the cold cylinder here into the hot cylinder. Once that's been drilled, I will bore this out to size, and this has to be fairly tight tolerances because we're going to be machining a piston that comes through here. Then I guess I'll flip the piece over, drill out the hole all the way through, and then bore this to the proper dimension. And then whichever side I have up, I will then bore the next step here. And then we'll flip the part and bore that last step. The final thing I'll do is cut these fins. I think what I'm going to do, the gap between these is only 55 thousandths. I think what I'm going to do is buy a tiny 55 thousandths end mill and just mill each slot, and then flip the block and mill the next ones. So that's my plan. Let's head off to the workshop. I've been working on the cylinder block. So far, what I've done is I've started with a raw piece of stock that was oversized, and I used my fly cutter to square the block and then machine it to the final dimensions as called out in the plan. Then I drilled and tapped some holes for the screws that will mount this to the helicopter. I'm not, in this series of videos on the helicopter, I'm not going to take you through the operations that we've seen so many times, like, drilling holes and tapping them and so forth. I'm going to concentrate more on the more challenging or interesting parts. The first of which is that I machined this boss on top of the cylinder block, And I did that on the lathe. Alright, what I'm trying to do now is get the cylinder block aligned properly in the four-jaw chuck. And if you recall, I center drilled a hole on the end to make that process easier. The problem is I was yapping too much and I didn't correctly set the XY coordinates, so that this hole isn't really in the center. So it's not going to allow me to do what I wanted to do. But I'll show you the technique anyway. What you do is you line up a center point here. I happen to have this. It's actually the extension arm for the Stirling tailstock, but you could machine something like this. All you need is a true round piece of stock that has a point on the end that you can use. And then, rather than doing what I'm trying to do, which is align a square, you can just put your indicator on the round stock and indicate it the same way you would a round piece of stock. It's a really simple way to do it. Unfortunately, I messed up. So now I have to indicate off a square piece, which is still doable, but certainly not as precise. I'm not sure that you can actually see the reading on the indicator, but I'm going to set it to 0 here on this side, and now come around to the opposite side, and that's within about 2 thousandths. And now these two sides, and again, it's because it's not a round piece of stock, you sort of have to fidget with it a bit, but I found that if you just rock it a little when it's near center, and you can almost sight along this line and tell when it is parallel to the bed. That's measuring 0 there, and the opposite side is just about 0 there. So, and I've been playing with this, so this isn't just an accident here. But these two sides seem to be aligned. This one, 2 thousandths there. So this needs to move a bit, and I always like to do this with two wrenches so that I can loosen one side and tighten the other at the same time. Alright, that's very close, and this turning I'm about to do here is cosmetic. It's not really a functional part of the cylinder block. So I'm within 1,000th or 2, and I think that's going to be fine. All right, I've begun to do the setup here for what we're going to do. Is come in 55 thousandths of turning and leave a raised cylinder here. The finished diameter of that cylinder is a little over 0.7. So
you know, it's almost impossible to know exactly where you are when you're working with an odd-shaped piece like this. So what I did was I brought the tool in so it just touched here and marked that as Z0. And then I brought it in until it just touched the side here. And I set that so that the X dimension is essentially equal to the, you know, diameter, what would be the diameter of this part if it were round. And then I brought the tool back out far enough so that, you know, it clears the piece. You know, because we're going to be doing an interrupted cut here. So I went into, you know, my little Mach 3 wizards that I use for doing a lot of the turning. And I set up a little turning program that will machine this down. It won't come into the final diameter here. I'm leaving about 20 thousandths. So that when I get to that point, I can stop, I can measure, reset everything to what the true diameter is. So anyway, we're ready to get started now. It's doing the finish pass. All right, so now we have that little cylinder there, and the machine thinks that that's 0.72 in diameter. It's very close. It's measuring 0.728. So that means my guesstimates on where the bit was were only off by 8,000. So what I do now is I'm going to bring the bit in to where the machine thinks 0.72 is. And now I'm going to go to the DRO and I'm going to tell it that that is actually 0.728. All right. So now I'll go in, I will modify the I'll modify the G code to pick up from that point. All right, so we'll just continue from there. Simple. quick sanity check. And it's 707 and a half, which is within 5/10. I'd call that close enough, especially for just a decorative piece. So that's it on the turning. So now I'll move this piece, back to the mill, and we can continue making the cylinder block. As I mentioned before, I accidentally put my center drill in what was not the center of this top surface. And unfortunately, my milling machine doesn't have an undo key. So I have to figure out how to undo this myself, and what I've decided to do is just take a 3/8 inch, flat bottom end mill, and mill down into this, to the middle of this hole here, until I have removed the mark that was left by the center drill. And then that will leave me with a flat surface that I can then use a center drill and properly set up to do the drilling operation here. So what I'm doing is I'm going to go very slowly, feed rate of about 0.5, to try to find the bottom of that. All right, well, I've gotten to the bottom of that, so to speak. So I'm just going to center drill now. All right, this depth is not critical. That's why I just did a very simple get close. All right, what I'm doing now is drilling this is the hole that will force air from the cold side of the engine into the hot side. So this drill has to go all the way down through to where the hot side of the cylinder is. All right, that's all we needed to do. So now the next hole is for the piston itself that has to go through this cylinder. So this has to be drilled out to the size of the cylinder, which is just a little over 1/2 inch. And the way I'm going to do that, and by the way, that hole does not go all the way down. That hole only goes to about 0.9 into here. The way I'm going to do that is just gradually use larger and larger drill bits until I get close to the hole size, and then I think I have a reamer of the proper size. and we'll just ream that. Well, it seems I'm having just one of those days. I told you that this hole here has to be 0.512 in diameter, and I have drill bits to take me up to that point, and in fact I told you I have a reamer that'll put the final size in here. What I didn't realize, because I don't normally drill holes this size, is that I don't have a drill chuck that'll hold those. My drill chuck is only a 3/8 inch chuck, so I was only able to get up to a 3/8 inch hole, and the reamer also, has a shaft that's larger than 3/8, so I won't be able to use the reamer either. So I've switched over to my boring tool here. The issue with this is that most of the tools I can think of that you run on the mill, you know what size they're going to cut. Obviously a drill bit, an end mill, and so forth. This doesn't work that way. With this, you have to sneak up on the size that you're working to. So it's a matter of cut, measure, and don't cut too much until you get to the right point. Through the magic of video, we've just time traveled 24 hours into the future. The video I made on that you were just watching of boring that hole, I realized later that I couldn't possibly have been adjusting this correctly. It was just too cumbersome. So I did some research last night and found the proper way to set the boring head. So I'm going to skip over the way I was setting it, which was incorrect, and then when we cut the next part of the cylinder that also uses the boring head, I'll show you the proper way to do it. So now we're going to go back to the past, and I'm going to show you the finishing step on the part we were just working on. This is a hole gauge. Get it down in the hole, make sure I'm perpendicular, and then I lock the spring here, and I just sort of tilt it out. Wow. Well, I guess Murphy's having an off day, because this is within 0.02 of what the hole was meant to be, and 0.03. That is, I'm going to call that close enough. And the reason is I have to machine a graphite piston to fit in this hole, and it's much easier on the lathe to to turn to a specific diameter than it is to mess with this, because we're trying to remove a thousandth or two with the boring head. At least I know there are people who can do it. I'm not one of them. So I'm going to leave the hole as it is, and I will simply make the piston, a thousandth or 2 thousandths larger than is called for. I mean, that's not going to make any difference on the working of the engine, and that works for me. All right, I've flipped the part and put it back in the vise. This time, because I have to go all the way through the part, I put a piece of black ABS plastic underneath so that I don't bore into the vise. Okay, the boring head. What I was doing wrong before, there is a screw here which loosens the dovetail that lets this slide back and forth against this part. And what I was doing every time I needed to adjust the fine adjustment here, I was loosening this screw so that I could turn this, and that's not the proper way to use this, because that just throws everything off. So what I read about last night was that what you're supposed to do is, snug this down, but not so tight that you can't turn this. So what happens is this is graduated in 1/1000th increments, and if you just turn it clockwise from where you are, you can actually count how many thousandths you are increasing the diameter of the cutter. So it's not as complicated to use as I thought. I was just doing it wrong. Anyway, I just finished drilling a hole here to get me started, and like I said before, the biggest drill I can get up to is 3/8 of an inch. This bore, which goes all the way through the part, has to be 0.728. So we've got almost double the size of this hole. So it's going to take a while, because I'm going to only remove, 10 or 20 thousandths per pass and work my way out. So I'll show you a couple of those, and then we'll come back when I get close. I want to use lots of cutting fluid. Now I'm using 1300 RPM on the spindle, and I'm advancing the tool at 2 inches per minute. I'll go down to the bottom of the hole, and then I'll come back out also at 2 inches per minute. And it's coming back out now. The wonderful thing about using a boring head is that it's going to give you a perfectly straight and concentric hole. Drill bits don't really do that. They're close, but not perfect. And even a reamer, if you don't have a completely rigid setup, you're not going to, to get a true vertical. The boring head will do that, though. So, what I'm going to do now is just, there's nothing really, there isn't a line to line this up to or anything, but I'm just going to look at this number 40, which is lined up basically at the bottom of the dovetail, and I'm going to go 10 thousandths, which means I'm going to bring the 0 up to there, like that. So that advanced the bit out 10 thousandths, and you just run that. I can probably safely remove 20 thousandths at a pass, so I'll try that on the next one. But like I said, there's a ways to go to get all the way out to where we have to be. So I'll get back to you when we get closer, and I'll fill you in on anything I learned along the way. All right. Well, I've continued the boring operation, and I've now gotten down to the final diameter, which I'll measure in a minute and show you. But what I found, I told you I had started off by taking 10 thousandth on a pass, and I cranked that up a little bit until I got up to about 20 thousandths, and that worked just fine. So I was comfortable taking 20 thousandths off on a pass, and then when I got closer, I backed off just to sneak up on the final diameter. The from measuring it using this spring-loaded it's a hole gauge. You put it in the hole. You make sure you're perpendicular to the piece and strapping down. You tighten this. There's a spring inside, and then you just angle it out. Yeah, that's point 0.728. So, which is exactly where we wanted to be. This is just not the best way to be holding this thing, but trust me, I did measure it off camera, and we are where we need to be. So, so anyway, so that hole is finished now, and it is it's through the entire part. The next step is to come down and make a recess we want to drop down 0.354, making a recess that is 0.787. Just checking the plans here. Yes, 0.787. So the idea is we're going to enlarge this this existing hole, but only down 0.354. So like I did before, I mean, we know now that where the boring bit is at 0.728, because that's what we just measured in the hole. So we can be a bit more precise here. I'm going to add 20 thousandths to that. And lots of cutting fluid. And Now it's coming back up. All right. Well, it seems I went just a wee bit over. That's measuring 7, 8, 9. 7, 8, 7 was ideally where we wanted to be, but I'm not worried about that. Again, that's not a. I mean, obviously, what annoys me is that I haven't really figured out how to get exactly where I want to be with this tool. But for our purposes here, we're going to be machining on the lathe a part that press fits in here. So, you know, it really doesn't matter. This actually could have been any dimension, as long as we matched it with what we turned on the lathe just to press fit it in. So, you know, being within a couple of thousandths is good enough for this. But I'm still going to work at trying to figure out how to get more precision out of this. All right, I've flipped the part over because now we have to bore a recess that's quite big. It's 0.925, I think. Yeah, 0.925 inches, which is almost the width of this entire block. I told you that I was, you know, going to try to do something to make this easier to use, and what I did, I hope you can see that, but I scribed a line here so that I have, you know, something to work against as I'm turning this dial. The problem I just realized is that I am at the maximum diameter that the tool can cut in this configuration. I mean, that's not a problem because you can flip this around, you know, to get much bigger holes. But the problem is that in doing that, this dial moves, you know, way out here, so, you know, this line is going to become much less useful than it would have been in the other configuration. So, I don't know what the solution to this is, but I am going to have to work from this configuration in order to get where we need to be, which is about there. So anyway, let me get this all tightened down and set up, and then we'll get started. I'm going to, off camera, I'm going to start to enlarge this hole, because you've seen that enough times. And when I start to get close again, you know, I'll start filming again. All right, I'm getting very close now. I just took a measurement, and I have 17 thousandths left to go. Even though there's quite a distance between this dial and the scribe line that I put in here, I'm getting better at it. What I'm going to do now is try to remove let's try 7 thousandths. Let's see if that really is 7 thousandths. Because even though it's better, it's still very difficult to see exactly what that is reading. So we still have about 10 thousandths to go, and I certainly don't want to do that all at once. But 1, 2, 3, 4. All right. I think that was another 5. Okay, that's 919. Wait a second. All right, so we've got 6 thousandths to go. Now we're at we're about 2.5 thousandths away from the ideal. I'm going to try to get a little closer. All right, it says we're at 9249. 9245. Anyway, we're within 5 tenths or less. Of where we want it to be, which is insanely close and certainly good enough for what I'm trying to do here. So I'm going to call that a wrap on that. I've begun doing the last machining operation on the cylinder block, which is to mill the fins to create the heat sink. I've already done one side, you can see that there. And now what I've just done is flip the part 90 degrees in the vise, and I've begun to cut the next set of fins. I'm using a 55 thousandths end mill, which is tiny. So I'm making very shallow passes. I'm only taking 20 thousandths off on a pass. And I'm only moving at a feed rate of 1. I've got a week invested in this part, and I don't want to, rush now and make a mistake. So, plus I don't want to break this very delicate and expensive end mill. So I'm just taking my time. I'll start it up and let you see how slowly it goes. And then I'm running just a tiny amount of air through the nozzle here, just to keep the chips like that. Just to keep the chips out of the way, so I'm not recutting the same chips. This operation could have been done, I suppose, with a slitting saw, if the part was standing upright. The problem is the slitting saws tend to be a lot thinner than this 55 thousandths, so you'd have to make several passes to get that much width out of it. It's doable, certainly. I just thought using an end mill would be of the exact size that I'm looking for. Would just be a better approach for me, anyway, on this machine. So anyway, this process to do all 4 sides is going to take about 5 hours of machining at these ridiculously slow speeds, but once that's done, the cylinder block will be finished. It will just need some sanding and polishing, and then we can move on to the next part. Here's the finished cylinder block. Well, the fins are complete. Well, obviously everything's complete. That's why we call it finished. All the boring that we did from both sides, and the bore from the top with the air hole passing all the way through. So it's time to move on to the next part.